We'll work through our last two examples a little bit more quickly, at least that process for setting up the integral, and then make sure we slow down to now look at how we'll evaluate integration by parts when we have a definite integral. So in this case, we're going to let u equal x minus 8 and dv equal e to the x. So integrating will give us v equals e to the x, and differentiating will give us du equals 1 dx, or just dx. So we'll get x minus 8 times e to the x for u times v minus the integral of e to the x dx. So this will become e to the x times x minus 8 minus e to the x. The integral of e to the x is just e to the x. But since we're dealing with a definite integral, we were evaluating that from 0 to 1. Now we want to evaluate this entire expression from 0 to 1. So we'll substitute the 0 and the 1 in for the e to the x, the part that we integrated, as well as that u times v portion. So this will become e to the first power times 1 minus 8 minus e to the first power, and then we'll subtract e to the 0 times 0 minus 8 minus e to the 0. So this will become e to the first times negative 7, so we'll get negative 7e minus e minus, this will become e to the 0 is 1. 0 minus 8 will be negative 8 minus e to the 0 is 1 again. So we'll get negative 7 minus e, this would be negative 8e plus 8 minus 1, or negative 8e plus 7. So integration by parts work just the same, but when we get down to that final expression, we evaluate it at both 1 and 0 and subtract those two results. So we could leave this as negative 8e plus 7, or if we were asked for an approximate decimal answer, type that into a calculator and come up with that approximate value. And in example 4, we have a trick that we talked about back at the start of these notes. The only function here is natural log of 14x, so we'll have to look at rewriting this as 1 times the natural log of 14x dx. We have a natural log function, so we'll let u equal the natural log of 14x. dv will be whatever's left over, so in this case 1 dx. Integrating will give us v is equal to just exactly x, and differentiating here will give us du over dx equals 1 over 14x times the derivative of that interior portion, so times 14. 14 over 14 will cancel, so we'll get du equals 1 over x dx. So we'll letting u equal natural log of 14x. That's our expression for u times our expression for v, which is x, minus the integral of v, which in this case is x, du, which is 1 over x dx. So x over x here will cancel, so we're just integrating u. So we're going to get x times the natural log of 14x minus the integral of 1 with respect to x will be x. And then we want to evaluate that from x equals 1 to x equals 3. So we'll get 3 times the natural log of 14 times 3 minus 3. And then we'll subtract evaluating that expression at 1. So this will become the natural log of 14 minus 1. So we get 3 times the natural log of 52 minus 3 plus the natural log of 14 plus 1, or 3 times the natural log of 52 minus 2 plus the natural log of 14. Or actually that should be a minus if we're distributing that negative through. So again, we could leave this as this exact result or plug that into a calculator to come up with an approximate. But again, following that same pattern, getting that expression once we apply integration by parts, and then since we're dealing with a definite integral, evaluating it at both the upper and lower bounds and taking that difference.